Hi everyone. Today I'm gonna share an idea which we'll be working on during AEC Tech Hackathon weekend. So without much ado, let's jump into the pitch. So I had several ideas when I started thinking about it, and ultimately I boiled down to this one idea. So it's generative modeling in Grasshopper using machine learning algorithms. So you take a input image and apply different styles to that image using neural style transfer algorithm, and that output of that operation will be used as input for another machine learning algorithm which will create depth map images, and then that output would be used to create 3D geometries using image sampler. So this aspect of the workflow deals with form explorations, and this aspect deals with form generations. So you start with one single building image, and then you can generate various different stylized 3D geometries. So in order to execute this, first of all, we need to convert this to uh, machine learning algorithms, style transfer and depth map, which are in .h5 format, to TensorFlow JavaScript format. Once we have those uh, ML models in JavaScript, the next step would be for our input, we do those machine learning operations locally, either in Grasshopper environment or on a web page. Then lastly, using that output, a GF script would be written to create different geometries from depth map images. Yeah, as you can see, style transfer basically generates different stylized content. So you start with a content image, and then you input different types of styles which you want to transfer in on your content image, and the result is a stylized image on your content image. The output of that can be used to create different depth map. I did a basic test run to check whether this workflow will work or not. So I started with an input image, and in Colab, I performed different style transfer operations. And you can see the style image on the left and stylized image on the right. Those input were then used to create different depth map images, which ultimately generated different 3D geometries using this Grasshopper script. Something which needs to be worked on this Grasshopper script is for those windows, a remapping component can be added to remove those voids for windows, and also a texture from the stylized images can be mapped on this geometry. The learning goals for this hackathon would be like, one would be able to learn how to deploy TensorFlow JavaScript models, how to create custom component and Grasshopper plugin, and how to send and receive information from Rhino-Grasshopper environment. Few other ideas which I had in mind, which probably I'll explore later, was what if Rhino modeling can be done using speech? So natural language processing algorithms can be used and paired up with Rhino common uh, libraries, and some wall components or anything can be modeled in Rhino. So the challenge for this workflow I foresee would be to filter out uh, words and decide what kind of event triggers would be there. But one can just say, hey Rhino, build a wall of this dimensions at this location, and this algorithm would be able to perform that operation. Another idea is generative sketch explorations using machine learning. So this was inspired from sketch-RNN exploration, which uh, basically had different classes of chairs, cats, and stuff, other various other objects. So I was thinking, what if we train on a architectural section model, and then one can use this training data to creatively develop different types of sections, and based on various human input, different types of architectural sections would be generated. And another idea I had was to deploy a StyleGAN model which I had trained on building flow plan. The challenge was how to customize it for particular project's constraint. So right now it generates some really good animations and uh, different insights about principal component analysis uh, are given out as part of the algorithm. But I wanted, what if we can apply it for our day-to-day task? Yeah, so that's it. I'm really excited for this hackathon, and if you have any feedback or suggestions, please feel free to comment